Hi, hello, welcome. My name is Tej Bhargav. I'm from uh, CSE Data Science. Today, I'm here to explain you about the electrical quantities from the subject BW. It contains electrical quantities, electrical charges, electrical current, electrical voltage, electrical energy, electrical power. Electrical quantities. To understand the operation of electrical circuits, we must familiar with electrical quantities such as charge, current, and voltage. Electrical charge. There are two types of charges, positive charge and negative charge. Conservation laws of charges. Charges can be neither created nor destroyed. It can be only transformed from one body to another body. The unit of charge is coulomb. Here we see the structure of an atom, like where electron, proton, and neutron, where nucleus contained in the middle. These all moves in an arbitrary state. There are three types of particles: protons, electrons, and neutrons. Protons are positively charged, and it has charge of plus 1.6 into 10 power minus 19 coulomb. Electrons are negatively charged, and it has charge of minus 1.6 into 10 power minus 19 coulomb. Neutron has zero charge. Coming to the electrical current. The rate of flow of electrons is known as current. I is equals to Q by T, where I is equals to current, Q is equals to charge, T is equals to time. If charge varies with time, so I is equals to dq by dt, where dq is equals to change in charge, dt is equals to change in time. Electrical current. Unit of current is ampere. It is denoted as A. 1 ampere is equals to 1 coulomb per second. 1 coulomb of charge is the charge carried by 6.25 into 10 power 18 electrons. 1 MA is equals to 10 power minus 3 ampere, and 1 nu A is equals to 10 power minus 6 ampere. There we see the electrical current. Electrical voltage 1 volt. A body is said to have a potential of 1 volt if 1 joule of work is to be done to give it a charge of 1 coulomb. Voltage or potential difference. Voltage is the difference in electric potential between 2 points. It is expressed in volts, V or joules per coulomb, J by C. Consider the two bodies A and B having potential 5 volts and 1 volt. Electrical voltage. So body A is at higher potential than B, and the potential difference between A and B is given by VAB. VAB is equals to VA minus VB is equals to 5 minus 1 is equals to 4. Voltages can be either positive or negative numbers, and it follows that VBA is equals to minus VAB. If VA is greater than VB, positive potential difference. If VA is less than VB, negative potential difference. EMF, electromotive force. The force which causes current to flow in the circuit is called EMF. It is defined as E. Its unit is volt. EMF is nothing but electromotive force which causes the electrons to flow in a circuit, like in the wire, like in a circuit. Electrical energy. The total work, the total work in an electrical circuit is called electrical energy. The energy over a time interval is found by integrating power. Work is integral P dt. E is equals to P into T. Energy is expressed in watt second or joules. It is expressed in electrically utility bills in kilowatt hours, kWh. 1 kilowatt hour is equal to 3.6 into 10 power 6 joules. Electrical power. Power is defined as the rate of doing work or the rate of change of energy, like dW by dt. Power is equals to work done by time. P is equals to I square R is equals to V square by R. Next. Unit of power is watt or joule per second or volt or ampere. 1 kilowatt hour is equals to 1 kilowatt into 1 hour is equals to 10 cube into 60 into 60 seconds is equals to 36 into 10 power 5 watt second is equals to 3.6 into 10 power 6 joules. Next, hope you understand with all these terms like electrical quantities. Like electrical quantities are like contain electrical charge, electrical current, electrical voltage, electrical energy, and electrical power. And after that, electrical current, we have electrical quantities. To understand the operation of electrical current circuits, we must familiar with electrical charges, quantities such as charge, current, and voltage. It's not like coming to the electrical quantities, we have like charge, current, and voltage, which we have to understand what is this charge and what is this current and what is the voltage. Actually, like electrical charge is like positively charged. There are two types of charges actually: positive charge and negative charge. Like conservation loss of charges. One thing we have, there are some laws for charges like how work can be we know one thing in physics like work can be neither created nor destroyed. The same way, a charge can be neither created nor destroyed. Only it can be transformed from one body to another body. Okay. The unit of charge is like coulomb. It is denoted by a C. Here we see the structure of an atom where there are electron, proton, and neutron revolving around the nucleus. Next, three types of particles. There are three types of particles: proton, electron, and neutron. Protons are like positively charged and it has positive the charge of 1.6 into 10 power minus 19 coulomb. Electrons are negatively charged and it has a charge of minus 1.6 into 10 power minus 19 coulomb. Neutron has zero charge. Next, electrical current. The rate of flow of electrons is known as current. I is equals to Q by T, where I is equals to current, Q is equals to charge, T is equals to time. If I varies with time, so I is equals to dq by dt, where dq is equals to change in charge, dt is equals to change in time. Electrical current. Unit of current is ampere. It is denoted as A. 1 ampere is equals to 1 coulomb per second. 1 coulomb of charge is the charge carried by 6.25 into 10 power 18 electrons. 1 mA is equals to 10 power minus 3 A ampere. And 1 nu A is equals to 10 power minus 6 A. Electrical voltage. 1 volt. A body is said to have potential of 1 volt if 1 joule of work is done to give it a charge of 1 coulomb. Voltage or potential difference or PD. Voltage is the difference in electrical potential between 2 points. It is expressed in volts or joules per second, J by C. Consider two bodies A and B having potential 5 volts and 1 volt. So body A is at higher potential than B, and potential difference between A and B is given by VAB. VAB is equals to VA minus VB is equals to 5 minus 1 is equals to 4 volts. Voltages can be either positive or negative numbers, and it follows that VBA is equals to minus VAB. EMF, electromotive force. The force which causes current to flow in the current circuit is called EMF. Whenever we need to push or something, we need some force in order to pull or push that particular something uh, charge. This force is known as electromotive force. Its voltage is nothing but its unit is nothing but volts. Next, electrical energy. The total energy in an electrical energy is called electrical. The total energy, the total work done in an electrical circuit is called electrical energy. The energy over a time interval is found by integrating power. Like work is equals to integral P dt. I is equals to P into T. Energy is expressed in watt seconds or joules. It is expressed in electrical utility bills in kilowatt hour, kWh. 1 kilowatt hour is equals to 3.6 into 10 power 6 joules. Next, electrical power. Power is defined. Power is defined as the rate of doing work or the rate of change of energy. Power is equals to work done by time. P is equals to I square by R is equals to V square by R. Unit of power is watt or joule per second or volt or ampere. 1 kilowatt hour is equals to 1 kilowatt into 1 hour is equals to 10 cube into 60 into 60 seconds is equals to 36 into 10 power 5 watt per second, 3.6 into 10 power 6 joules. Now we come into the main topic, nothing but numerical problems. Okay. Given a circuit has a voltage of 12 volts and a resistance of 4 ohms. What is the current in the circuit? So here we use the basic formula of the chapter. It's nothing but Ohm's law. We know that current is directly proportional to the voltage, or voltage is directly proportional to the current. We know that voltage is directly proportional to current, that is V is equals to IR. So from there we get I is equals to V by R. So as per the question they have given, they told that voltage is 12 and resistance is 4. So I is equals to 12 by 4. So I is equals to 3 ampere. We know that current has the unit of ampere. Here we used a very basic formula, that is nothing but V is equals to IR. We know that voltage is directly proportional to current constant uh, at constant temperature. So V is equals to IR, and from there we got the formula I is equals to V by R, and from there we have substituted the values given by the question, and at last we got the question answer, that is I is equals to 3 ampere. Next, next the question is the circuit has a current of 2 ampere and a resistance of 5 ohms. What is the voltage in the circuit? Okay. Same, we use the Ohm's law. V is equals to IR. He told to find the voltage. So V is equals to IR. So I is given as 2 ampere and R is given as 5. So 2 into 5 is nothing but 10. V is equals to 10 volts. We know that voltage has units volts. So circuit has the voltage of 10 volts. Next, problem 3. A circuit has a voltage of 6 volt and current 2 ampere. What is the power? Here comes the basic formula of power. Power is nothing but is equals to V into I. P is equals to VI. V is given by as per the question as 6 volts, and current is given as per the question as 2. So P is equals to 12 watts. You need to know that like unit of power is watts. So our answer is the power flowing in the circuit is 12 watts. The circuit has power of 24 watts and a current of 3 ampere. What is voltage in the circuit? We can use the formula of power and Ohm's law to calculate the voltage in the circuit. We know that P is equals to V into I, power formula, right? 24 is equals to V into 3, given like power is 24 watts and current is 3 ampere. So 24 is equals to V into 3, like V is nothing but 24 by 3, so V is equals to 8 volts. You know that voltage SI unit is volts, so our answer is 8 volts. Next, uh, next. Next, given that a circuit has a power of 75 watt and a current of 3 ampere, what is the resistance? Here we comes the formula. We know that P from previous slide, when we go into the previous slide, we know that P is equals to VI. P is equals to VI. Here, V can be written at I square R. See, P is equals to VI. So, we know that V is equals to IR. So, P is equals to VI, nothing but P is equals to IR into I, nothing but P is equals to I square into R. Here we split the formula P is equals to I square into R, because we know that power P is equals to VA. P is equals to VI, and V is equals to IR from the Ohm's law. So P is equals to VI and P is equals to V is equals to IR. So IR into I is nothing but I square R. So P is equals to 75 watts. 75 watts is equals to I square, means 3 square into R. So 3 square is nothing but 9. So 75 is equals to 9. R is nothing but 75 by 9 is nothing but 8.33 ohms. Like here we used the two formulas. Two formulas majorly played a role here. Like that is nothing but P is equals to VI and V is equals to IR. Both these formulas had majorly influenced this problem. Next, which finally gave the resistance like 8.33 ohms. You know that SI unit of resistance is nothing but ohms. So finally, we got the answer as 8.33 ohms. Next, given that a circuit has a voltage of 24 volts and a resistance of 3 ohms, what is the power in the circuit? Okay, what they asked is like power. We know that P is equals to VI. P is equals to VI, and but here we came to here what they asked as per the question they asked, we know that V is equals to IR. P is equals to VI and P is equals to VI and V is equals to IR. So we know that I is equals to V by R. See here again, our formulas has been split into two types, like two types of formulas have been majorly influenced this problem. We know that basic formula we know that P is equals to VI, and also from the Ohm's law we know that V is equals to IR. From there, I is equals to V by R. So in place of V is equals to P is equals to VI, we put V into in place of V we put V by R. So here V square by R. P can also be written as V square by R. So as per the given question, V is 24, R is 3. So V square is 24 square by 3. So power P is equals to 24 square by 3, which is nothing but 192 watts. So here we get the power from this formula, from this formula V square by R. Here majorly two formulas played a role, that is P is equals to VI and I is equals to V by R, which is nothing but V is equals to IR from the Ohm's law, which have been learning from the starting. Okay, here we calculated the power, which is nothing but 192 watts. Okay, next, coming to the next problem. A circuit has a power of 100 watts and a resistance of 50 ohms. What is the current in the circuits? Look, we know that P is equals to VI and V is equals to IR. So as per the questions, here he gave only two, two quantities. That is P is equals to 100 watts, and resistance is equals to 50 ohms. So what he asked is current, but P is equals to VI. He gave only resistance. But as per the formula we have, P is equals to VI, we don't have the resistance to use. So what we do is, like, we know that one thing, V is equals to IR from the Ohm's law. So in place of V, we put IR. IR into I is nothing but I square R is equals to P. So P is equals to IR, I square R. So P is equals to I is nothing but given as 50, 50 square. Sorry, I is not given, I square is not given, and R is given as 50. So 100 by 50 is equals to I square. I square is equals to 2. I square is equals to 2 because 100 by 50 is nothing but 2. I square is equals to 2. I is equals to square root of 2. Square root of 2 gives 1.41 something, like 1.4132 something. So here the I is equals to 1.41 ampere. So majorly here, what the formulas have been played role is P is equals to VI and V is equals to IR. Both these formulas majorly taken our problem, had influenced our problem, and hence we found the current, that is nothing but I is equals to 1.41 ampere. So far whatever we discussed the formula problems, like from the starting, the first one we used the basic formula P is equals to VI, sorry, P is equals to no, here we calculated correct. So V is equals to IR, the basic formula from the Ohm's law, that V is equals to IR, that voltage is directly proportional to the current at constant temperature. V is equals to IR. From there, I is equals to V by R. And later on, we used V is equals to IR formula. Next, in the next problem, we used P is equals to VI. The basic formula for power is P is equals to VI. And here we use P is equals to I square R by I square R into I square into R, because P is equals to VI, and we know that V is equals to IR. So in place of V, you put IR. So IR into I is nothing but I square. So I square R, P is equals to I square R. So hence we got that, we found that particular value. Next again, P is equals to V square by R. Here what we did, P is equals to VI, we know that, and V is equals to IR. In place of R, you put V by R. In place of I, we put V by R. Because V is equals to IR and I is equals to V by R. So P is equals to VI. In place of I, you put V by R. So it gives V square by R. So hence we found the particular problem, like particular power of the particular circuit. And later here we use P is equals to VI. In place of V, we put IR. So again, IR into I is nothing but I square R. Hence we calculated the power. So far we have discussed electrical quantities and electrical charges, voltage, current, and structure of an atom, three types of particles, electrical current, voltage, electrical circuits, and electrical and EMF and electrical energy and electrical power and problems. So all of you have understand the topic, like voltage and voltage, power, and numerical problems regarding it. And hence we come to an end of our PPT. I thank you for giving this an opportunity. Hope you all understand with the topic. Hope all you are uh, well known about the numerical problems of power and voltage, and between the power, voltage, and current. Thank you.